So we're going to go into 4.4 graphs of sine and cosine functions. And we're also going to include transformations, so just graphing sine and cosine function. But in this class, we're just going to focus on the transformation given the equation, not so much of graphing. But you still need a basic understanding on how to graph as you progress into your higher level math classes. There will be some graphing, that's what you should expect. So make sure to have some basic understanding. So let's go over the properties of the sine and cosine function. Now in this left column, this is the sine function. Now I'm not going to require you to copy the whole information. What I do require you to have is the information on domain, range, the x-intercept, the end behavior, and the picture of graph. Now, domain, as you can see, it's continuous towards the left and towards the right because, as you can see, it's an arrow on both ends. So it just meaning it's going to go on forever. Now, the range is going to be between -1 and 1. As you can see, it goes up and down like a wave. So the range is from -1 to 1. And as you take a closer look, it has brackets on both of them. So it ties into where it says oscillation between -1 and 1. So oscillation, if you tie in or connect with physics, it's a wave going up and down or back and forth. So that's what I mean. Now our y-intercept is at 0. Now our x-intercept is n pi, where n is a natural number, n is a variable. Well, whatever n is, your x-intercept will always be at pi. So if n is 7, you will have an x-intercept where x equals 7 pi. If n is -3, you will have another x-intercept where x equals -3 pi. Now symmetry, not going to go in much detail, it's an odd function and it's a metric about the origin. Now the extremas is the maximum and minimum. There's a maximum of 1 at x equals pi over 2 plus 2n pi, where n is a subset of natural numbers. A minimum of -1 at x equals 3 pi over 2 plus 2n pi, where n is a subset of natural numbers. So again, you're not going to go in much details, but if you were asked to find maximum and minimum, you will use this formula. Now your end behavior, which I did say you should copy that down, as the limit of x approach to -infinity going towards the left side, and as the limit of x going towards the right side, sine of the sine function, they do not exist because they, what you call it, diverge, they go both separate directions. And as you can see, it's an oscillating wave, so it's going to go up and down between -1 and 1 or back and forth. So there is no set value for end behavior. So again, I did mention that you don't have to copy down the whole information, just the specific domain, range, y-intercept, what else, end behavior, and the picture of the graph, including the information that's written. For example, period is 2 pi, this is sine x. Now cosine x, or cosine function, so I do want you to have down domain and range, same thing with the y-intercept, the x-intercept, end behavior, and the graph. So cosine function, domain is pretty much the same, -infinity to infinity with parentheses. The range is -1 to 1 with brackets. The y-intercept is at 1 as you take a closer look at the graph. The x-intercept is pi over 2n, where n is a subset of natural numbers. So you always have x-intercept when it's pi over 2 or pi or 3 pi over 2, wherever n, what number n is. It's continuous from negative infinity to infinity. As you look at the graph, there's arrows on both ends. Goes on forever. The graph is an even function, symmetric about the y-axis. Now your extrema maximum of 1 when x equals 2n pi, where n is a subset of natural numbers, meaning n, whatever n is, you will have a maximum of 1 at, for example, 2 pi, 4 pi, 6 pi, and so on, including negative ones like negative 2 pi, negative 4 pi. So you kind of see a pattern there. The minimum of negative 1 at x equals pi plus 2n pi, where n is a subset of natural number. So what it means that you have a minimum of negative 1 where your x values is odd number. So pi, 3 pi, 5 pi, 7 pi. Same thing with negative. Negative pi, negative 3 pi, negative 5 pi, negative 7 pi. So there's a pattern. The end behavior is pretty much the same as sine. As the limit of x approaches to negative infinity, cosine x, and as the limit of x approaches to positive infinity, cosine x, do not exist. So again, it's oscillating, meaning going back and forth, up and down, not to a set value. So that's why there's no limit. And of course, oscillation between negative 1 and 1, that ties into the range. So pay very close attention to the graph. Now, there's some small information on the bottom. The portion of each graph, the sine graph and the cosine graph, on 0 through 2 pi, so basically tying to the unit circle where it's from 0 degrees to 360 degrees, it's the same thing with radians, from 0 to 2 pi. So when it comes to graph, it's mainly going to be in radians, not degrees. So keep that in mind. I think you should highlight that information. When it comes to the graph, when we're talking about transformation, it will be in radians, not degrees. So the portion of each graph on 0 to 2 pi represent one period or cycle of the function. Notice that the cosine graph, the one on the right, is a horizontal translation of the sine graph. So if you compare with the sine graph and the cosine graph, it pretty much looks the same, but if you look closely in regards to the y-axis, like you see that in the middle of the cosine graph, the y-axis go through it. But in the sine graph, it looks different, as if it was shifted either to the left or to the right. So it is true that the cosine graph is a horizontal translation of the sine graph. Any transformation of a sine function is called a sinusoid. The general form of the sinusoid functions, sine and cosine. So when we're talking about sinusoid, it refers to sine and cosine. So the general form of the sinusoid functions, sine and cosine, are y equal a sine of bx plus c plus d, and y equal a cosine of bx plus c plus d, where both a's are the coefficient for sine and cosine, and b is the coefficient for x. Below, where it says a, b, c, and d are constants, and neither a nor b is 0. So that you should also have in your notes, because when we talk about transformation, we're going to be using this general form, and you're going to be tasked of finding the values of a, b, c, and d, and then use them to determine what kind of transformation within the equations.